Hi, everyone.
Hey,
Hello.
Mark. Hey, everyone.
I'll just give it another minute or two and then we can get started. Hi, Rajesh. All right. I think we can get started. We may be a little bit like not as many people today. I know Kash is out because I think he's traveling. I'm not sure, like Anu may join later, but we'll see. So first, one thing I wanted to mention, last week we had discussed the possibility of having other people come in and give talks. I did reach out to Professor Gupta from UCLA, and he was very happy to give a talk. I'm not sure if it's him or his student. So this would be specifically on the topic of a chiplet cost model. And I believe I'd sent this, I certainly put the link in the meeting notes. I'm not sure if all of you have gotten that. Otherwise, I'm happy to put it in the chat here as well. But they would be able to give us a talk on that work on October 27th. I think we set as a tentative date. And they did say that they're currently working on some updates to it. So it sounds like we would be getting kind of a presentation on the updated version or whatever changes they have done in the meantime.
Marek, the link that came in the email was broken.
Yeah, so it has a security thing, right? Like I think it's just like something weird that it either says it's HTTPS, but it's not, or like either way, if you click on the like advanced and allow, you'll see the PDF document. So this is like this was published at one of the conferences, and I guess if you look for the title, and I'm not sure if you guys like have access to journal papers, but this like if you click on proceed with the risk or whatever, then you will see the full PDF. Like I've seen the same issue on my end.
Did you mind putting it here in the chat? Because in my case, it was just that it didn't exist. It wasn't even
Okay,
a security
okay,
thing.
yeah. Let me try, and I can share my screen. Just have to go into the meeting notes. But there's also a good chance I have messed this up and somehow the link itself is broken. So in that case, I'll try it live and see what happens. So
No problem.
Okay, I'll share this one here.
It says internal server error.
Oh, I see. Okay. So cost model. Oh, you're still not seeing me. Here we go.
It seems that the server may be down or something.
Oh, snap. Okay. Well, that would be unfortunate. We cannot.
If you know the
Oh,
professor,
my internet has been
let him
kind of.
know.
Yeah, I guess I could do that as well.
I think he will
I don't
be.
know why Google is. Somehow my computer has been
That's
quite
okay.
slow.
Yeah.
Okay. Oh, here we go. Okay, so yeah, so that's at least the title of the paper. The how small is too small. And I haven't like I've kind of like skimmed through the paper. It looks quite reasonable, like how they're approaching it. They are coming up with different kind of different recommendations for. Oh yeah, okay. So then that is new. That wasn't there before. Okay, so then I will see if I can find another link for this.
Yeah, not to belabor, but I went to their website and then tried to kind of poke around, try to find a chip, the cost model. It's a huge website.
Yeah.
So
Okay. Yep, sounds good. Okay, notes taken. So then I guess I will still follow up on this and send like hope find a good link so that I can include in the meeting notes for this time.
thank you.
And I guess maybe I should just download this next time and then I can attach it via email because it was just publicly accessible for a while at least. Okay, so then otherwise I would talk more on our white paper. I finally had, or I guess I made enough time this week just go through each section and add some more comments. So I wanted to go through these comments as a group, and then I think I'll send it out as an email later on, but I think now would be a good time for every author to read through the entire document and basically put down their thoughts or comments on things they would change, because I believe that for most of the sections we have we've already added material, we've pruned the material down, and now it's just making sure that it all looks right and that we're not missing anything. Does that sound good?
Sure.
Yeah.
Yep.
Okay, so let's see. I'm gonna go back up. So right now we're at 21 pages, but I think that will break down to 20 since I put in page breaks after every section, and so sometimes we have a fair amount of white space. So I still have one item to do here in the introduction to reference the chiplet challenges talk series that we had in the ODSA earlier this year, and then kind of weave it into the text that this white paper is a response to that. I've been reaching out to Bapi, like again, still on that image with the value chain, like all the companies related to chiplets, and he confirmed that he has the slide, but he hasn't sent it to me yet. And the other item specifically for the intro was that there is this slide on like the chiplet value creation, or basically like the whole value chain of from design to then eventually like packaging, test, to having a final product. And I think his thought was that we could also use that in the introduction and say, like, just at kind of at a high level, say you need to move some of these items later in the value chain. You have to pull them earlier into your design cycle because now everything is connected. For example, that your interfaces and packaging have to be well aligned, and even the test strategy has to be clear when you're designing the chiplet based system. So that's to-do items for the intro, but I can take care of that and I'll follow up with Bapi on this. Then secondly, chiplet architecture we talked about last time, so I think that part is very good and in great shape. There were I think this yeah, and Anu had addressed this, so I can take that comment off. And we do have to, I'll just make sure that we see it. So I can put that one in. So then die-to-die interfaces, items that are open still here is the like linking this back to the spreadsheet that Shahab is working on. I had reached out to him, haven't heard back, so that's an item for me as well to reach out again. I think I know that there is this workshop where they're basically where they want to work out the parameters that all IP vendors or PHY vendors agree on, so that things are measured the same way. I don't think I would be happy even to reference to like a spreadsheet that they had before they're normalizing it to that. I'm not sure if they have like a complete version of this, or if we would have to reference this to the earlier version that is complete. Does anyone have insight or is taking part in that meeting?
Yeah, so Marek, they have the older one. The newer one is being worked on, and I don't know if Shahab's going to finalize all of that after the meeting on October 16th, where he's got a whole bunch of people presenting about their PHY.
Right.
But
Okay.
he does have a new, his new figures of merit and stuff, but it's not filled out by all the die-to-die PHY vendors. So probably getting a link to the previous version should be good enough to start with.
Okay. Yeah, because then I think we could even add something to say like this is the previous version, but they're currently working on another one, and I assume that they would also publish this as a link or something on some ODSA website.
Yeah, I'm pretty sure it'll be on the website.
Okay. Do you by any chance have the link to the previous version?
I'm just looking through my my Google Docs at this point.
Okay.
Yeah.
Otherwise I can also ping him and say just send me what you
Yeah.
have. And okay. All right, so I went through the die-to-die interfaces. I mean, this is the section I had written, so I just changed a few things based on, like, I think pulling in, Akash had written something about both bunch of wires and UCIe. I incorporated that into the paragraphs that I already had, so that it wasn't, so that it was kind of like centralized in one place rather than talking about it in various places. One question I have for the group is I still have AIB in here as an interface. I am mentioning that, like, and this is public information, that Intel is now, like, even for their announcements for FPGAs, they are saying that UCIe plays a critical role going forward for the next FPGAs, which to me is basically their way of saying that there is not going to be AIB on those FPGAs, and as a result, it is unlikely what I said here as that it will be proliferated as an ecosystem. However, kind of on the flip side, this is kind of the first prototype of an ecosystem, even if it's limited, and there are dies from various companies available, or chiplets available. So what do you think in terms of kind of like backwards looking versus forward looking? Should we include AIB, or just say that by now it's mainly down to a bunch of wires, UCIe, and basically proprietary interfaces that are often XR or USR based?
It may be used by the associate teams for other projects as well. So AIB, I do see use is not only for FPGA. Yeah.
Okay. No, that's true, and I know that it's like, and it is this, like, it is open source. So I'm just wondering, I guess.
So
yeah, I guess you being from Intel, you can comment maybe further.
Intel statement is just that there won't be future developments, but it's in the maintenance mode only. So, but it doesn't mean that it will not be used, because the IP is already developed and the file is ready for use based on the projects needed per se. So there is no say that it will be fully disbanded. That is the statement. So should not be too conclusive, because IP once developed, they will keep and use as per needs basis based on the project needs. It may not be on the FPGA, but on the other custom chips instead.
Okay, so then do you think basically what I have here looks okay, or would you or you can also do this offline just to double check that basically the paragraph, like it sounds like to me that there is still a especially if there is a commitment to maintain at least what is there, that like that would be enough of a reason for me to keep it in here, but then just to make sure that the wording is accurate.
Okay, I will read again tomorrow morning instead.
Yeah, no, I mean, it does can also be by next week or so. Like, it doesn't have to be. It's not super urgent, but yeah, and not sure what other people think, but I guess like if Boone is here and has kind of insight from like the inside scoop from Intel, then I think that is a good voice. Okay, that's good. So this is about 2 pages. Then chiplet packaging. I will reach out to Trent offline since hasn't been able to make it recently. I've edited like the section just a little bit. I think overall it's very nicely written and has a lot of good information, especially here like tables about pricing and just the general availability or like the general kinds of packages. As I had mentioned last time, I moved all the detailed descriptions of, say, what is an organic buildup and what are the versions, what is an interposer, and so on. I moved that to the appendix and referenced it accordingly in the text so that people can go there. I started adding links to those sections so that people can basically jump back and forth within the document as well. So that one also lengthwise now is pretty good. So we're at like about 3 pages for the packaging. And I think it covers like again, keeping in mind this slightly business like technology plus business oriented viewpoint. I think that it fits that very nicely. So then for test and probe, Rajesh, I had some time going through this and had a couple comments, and we can talk about it now if you want.
Yeah, go ahead.
So I think I definitely like the introduction, and I really appreciate your focus on the cost aspect of things. I know that there is also a lot of technology involved with probe and test, and what you're calling out specifically, always going back to, well, how much is that going to cost us in the end, is definitely the core of the paper. So that's very good. I had one thought, just kind of like thinking about like zooming out a little bit and thinking about like a reader that doesn't know much about test and probe. I probably would add a little bit of a section to talk, just even in the paragraph, to explain why knowing the die is more important for chiplets than it was before, because I think the term has been around from before chiplets, but even and I think it's like in many talks you see this like one way or another, people expressing this idea of, say, 0.9 or 90% yield time, like to the power of 5 or 6, however many chiplets you have in there, and how that number quickly goes down, and that basically you have this high scrap cost because of it, and that ties in with basically the lack of repairing die. Like we talked last week about die-to-die interface repairability through spare lanes, but I think this assumption of if you have multiple chiplets in there and one breaks, you have to scrap the whole package, is because people are generally acknowledging, like, yes, you can't take a chiplet off and put another one on. So I think describing that somewhere in the beginning would maybe steer people to at least appreciate the reason why we want to have better insight into or need better testability at the die level.
Oh, okay. I think that's a good point. That will be a good introduction since it's a business paper. Yeah, I can add something because KGD has been there for last more than 30 years. So explaining that in maybe 2-3 sentences, yeah, I can manage that.
Okay.
Marek, so since you speak about those good die and how does yield impact the gross margin, right? So perhaps we should include the table of the illustration. I think I saw one of the articles that illustrate how the yields impact the gross margins with the chiplets in one of the
Oh, okay.
paper. I forgot where, but I think I saw it as within the ODSA. There's some paper written from this aspect. Maybe we should include the ones here so that will show the why the non-good dies are important and how the post-assembly yields actually impact the overall gross margin. There is one written paper from this aspect.
Okay, yeah, no, I mean, if you can dig up that reference, that would be excellent. And I think depending on how big the image is, we can. I'm not sure how much like area we have to put in additional images unless we take out something like this example of the 3D stack. But at the minimum, I think we should link out to that paper and say like this. You can find further explanation in that place.
Yeah. Okay. So let me dig it out from tomorrow and also put a comment there. So where to check. Yeah. Okay.
Okay. Great. Thanks. So then down here to the second half. I had a couple comments about here these other two sections. So after kind of reading through it and thinking about it at the paper level, it seems that it's basically just a list of a lot of things, which is helpful if you ask somebody to, hey, what do I need to consider? But I think it doesn't necessarily, like somebody that doesn't know what each of these terms mean probably can't do a whole lot with it. So my thinking or suggestion would be if we can kind of like keep the content of this, but rather write it more as a paragraph and even in kind of like half sentence explanations, or at least for some of these terms to like explain what this is and why we need it. So kind of like we could like still use exactly the structuring that you have. Like you could say something like at the die level, there are these and those tests, and they basically start at probing the wafer, looking at the wafer, like basically trying to get to the point of what is functional test, what is like what cost do you see for test generation, or like basically just explaining somebody the fact that these test programs have to get developed, which also costs money. Yeah, so
yeah,
does that make sense?
Yeah, it makes sense. The reason is I think this
To just
when
have
I
this like
wrote
elaborate
this,
it a little bit more.
I think when I
wait.
wrote this, it
You're
assumed
speaking. I
little bit.
can't hear you. I think that's again my audio issue. Sorry, let me just
Can you hear me?
fix my.
Yeah, I can hear you, Rajesh.
Okay, I think Marek has some issue. Okay, let
Yes,
him
sorry,
come back.
I can hear you now again. This happens every once in a while.
Yeah, no,
Okay.
no worries. Yeah, okay, actually, yeah.
So,
Point well taken. The thing is, when I wrote this, right, I think I assumed some sort of exposure to semiconductor design and test, and I think that's the reason I might have assumed. But I think, yeah, it makes sense. I can simplify that, and if you want, I can give one example. So at least a person who is not in that, I mean, comes from business side, he can take even getting a tool and to run the tool on a compute, and everything is basically costing us money, right? So that is what I mean by test generation cost. And then getting, depending upon what process you are, your testers also equipments also change dramatically from low cost testers to advanced, very advanced testers, and that everything is basically cost you, whether you want a very high power, depending upon what your chiplet is, or you can use very cheap ultraflex tester. So yeah, I can add basically restate into some layman's statement if you want.
Yeah, exactly. Like, and I think that goes towards my second comment here, which is exactly what you're saying. I think if you know about this topic, then all of this makes sense. But even at the simplest level,
Absolutely,
I think
absolutely.
being able to say like, hey, test cost ultimately is basically test resource dollars by test time, like multiplied by test time, and so and now you have to do several trade-offs, like basically how complicated is your test, how much is that going to cost you per hour, and how long is your test, and if you want to get to better, basically higher test coverage, like having higher chance of covering everything, then you'll spend more time, and so that's more money. And then saying that it is a sweet spot, basically.
Okay. And if there is a scope, I can reduce the sort of words and add one of there is one graph I can procure.
Yeah.
How the testing cause explores order of the magnitude if that test is not done at the die level, chip level, system level, and board level and system level. So it is like that's a good graph, although it is old, but the truth still stands. So I can add that.
Okay. Yeah, that sounds good.
Okay,
oh,
sorry,
thank you,
Marek,
Boon,
what
for-
happened? I did not get chance to go through your comments, but good. At least my thoughts are same as what you have commented. I'll go back and recheck your comments and maybe streamline that.
Okay. Okay, that sounds good.
But include the table.
Sorry, you're a little like faint to hear. I'm not sure if that's just on my end.
So I
better.
include the figure already.
Okay, perfect. Yes,
Okay.
I can. Oh, that's from the okay, from the POC Workstream. Right? Yeah, okay, that looks great. I'll look into the is that a document or a presentation?
PDF file.
Okay. So I'll look at that, but that looks pretty good. I think at the end we can then decide whether we keep it as a graphic
Yeah.
or whether we just reference it in the text.
I also provide the link in the comment where to get it.
Okay.
Yeah, this was actually trying to think. This KGD was done by a gentleman from Teradyne
Okay.
as part of this paper that you shared, Boon. His name is on the list, but yeah, you could always reach out to him if you have a question, Marek.
Okay, excellent. It's good to have here some people that know more history of ODSA.
Yeah, Roberto from Teradyne. I see his name on the author list.
Gotcha. Okay, awesome.
Has you shared this paper in the chat? Boon?
Yeah, he
So
shared it.
Boon
Boon
puts it here.
link.
Put it here as the
Yes.
Oh,
Comment
okay.
as well in the
I
chat.
can
Yeah,
put
comment as
it
well
as well.
chat.
Yeah, okay, because there is another one which, if you remember, maybe Anu, I don't know whether you attended. There was another talk by, I forgot the name of the company, and they had a nice. Maybe I had to recall and get that reference. I can put that also.
Was
Thanks.
it for KGD or was it for cost model?
Not cost model, but since I come from test background, there was some test DFT
Oh,
related
okay.
stuff.
Oh, that'll be useful.
Yeah.
If you could share the link, that would be great.
Yeah, I mean, I can add that in my section just to give the.
Yeah.
I think it was
So-
presented here in OCP.
Oh, I see. Okay. Yeah, I'm wondering if you're talking to the same gentleman from Teradyne because he presented at the Friday calls. This was like more than a year and a half ago. But no, I would be great
Yeah,
to see your.
I missed this Teradyne. I don't remember. Otherwise, this would be
Okay.
a good resource. Okay, thanks.
Yeah.
Yeah, and I think maybe another, like, I'm not sure if that's what you're talking about. Like one of the graphs that I've often seen kind of more visually to like present test issues is kind of to show like a flow chart of chiplets being assembled into a package. So like kind of starting on the left-hand side with a couple of wafers and then going to say like some of them like will be probed and some of them will have burn-in, and then they eventually will get packaged, and basically showing that flow and then labeling the possible test insertions. So that is kind of coming back here to even this side. It doesn't have to be comprehensive, and I know you added here a lot of tests, and it would be if we showed all of these in diagram, people would probably lose their mind. But if we just use the most typical ones, then that may be another nice visual way of explaining what is happening in the flow of assembling chiplets. And then what I've often seen like people do is kind of like just drawing arrows of saying, like, for example, some of the test content from final test has to move to something earlier in the value chain, like at the probe level, for example, so that you're basically shifting test coverage around and maybe adding like a system level test or something. Have you seen some of those charts, Rajesh? I think you're muted if you're saying anything.
Okay, sorry, I was muted. Yeah,
Yeah,
what
no
I was
worries.
saying that 4 bullets which I've shown here that can be converted into chart, and that was sort of in my mind too, because
Okay,
it is already in my mind, but I did not get a chance to put that figure. I said, oh, at least let me put the bullets, at least I won't forget. Then I will convert it into the figure. Because finally
Okay.
the assembled test is directly proportional to how much good die you are getting and how much coverage you are getting. So final assembly test is I can show as a final product.
Yeah, exactly. Okay. Yeah, then that's I think that's even better if we can make that as a visual plus like a little bit of
Yeah,
accompanying
got it.
text. But then people kind of get intuitively the view for like there are many ways of how you can do this. And I like your paragraph at the end, which I think for somebody who appreciates the nuances of what you can do, I think I like that vision of saying you would like to develop a model and being able to basically get the optimal way of testing what at what point so that it's cost optimized and yet satisfies the needs you have in terms of quality. But I think that's like that's maybe easier to convey with an image where you say there are many ways you can tweak this and you just have to find the right parameters.
Okay, all good.
Okay.
I
So then, yeah.
Marek, I am actually when do you need this by?
I mean, I know this is kind of like
Before
for a
next
lot of people
week, right?
on the that would be nice. If is so, I think these are like now the like more final changes or
Yeah,
like
yeah.
things that I know are like sometimes a little bit more involved. It would be nice if you could have it by next week, but if it's in 2 weeks, then so be it. Like I think I know this work is often for like for a lot of people just on their spare time.
Okay, okay.
So and then this other one here, this trade-off analysis, I see it like this one I feel like is getting even more in the weeds of than the first one, and I'm not sure how we can best like one thought for me would be to say like maybe this is too detailed and we move it to the appendix and then also have a little bit of explanation, because like ultimately I think what you're trying to say here is there are a ton of parameters underlying this like such a model if we were to get kind of a comprehensive test model and all the ways we can achieve a fully tested system in the end. And I think like if we start explaining the first level, then these parameters are underlying what you would be doing at the die module interface and repair level. But I'm not sure if we want to go into that much detail.
Yeah, that is fine, because this I was trying to basically that I'm envisioning is actual software. I think it was already presented at some other conference at Berkeley that you can plug in, put all these numbers, and you'll get the expected
Gotcha.
final cost. Yeah. So I just
Okay.
thought this may be too much detail. Yeah, we can put some in appendix is fine.
Okay. Yeah, and then lastly, can you explain a little bit this table here, what your intention was? I think you're muted again.
Okay, so basically, what you wanted me to put it in earlier those parameters, I just listed in a tabular format so that it is much clearer for any person who is not test savvy.
Gotcha.
Yeah, right? Sometimes table makes much sense. They will not be able to read all the bullets I put. So these are what exactly you
So
wanted
this,
me to, what cost factors are there, but then once I put a figure, then it will be much clearer which row in that table, in this table corresponds to which figure. I mean, I have not yet added it, but these
okay,
are what
okay.
happens in each level, right? So you can take each row as a cost contributor.
So then I guess because the die-to-die interface is, my assumption would be like that I would then structure it more like you have it described here, with like diamond level, module level, which I guess is more like or substrate level, then because the interface, I think, like breaking out the interface separately is more like, I would either think of it in terms of like, when do you do the test, which is like, from my understanding, you do it at the wafer, or you do it at, say, like
After
singulated die,
assembly.
or you do it after assembly. Exactly.
After assembly, yeah.
So to me, all those levels are not necessarily apples to apples, if that makes sense. Like, I would then rather have something like a final test, for example, is something I've seen like people like refer to as kind of a standard semiconductor flow. And so I would kind of think about like die level, like wafer level, die level, like sub assembly level, and final test, if that makes sense. Like,
Yeah,
that's, I guess,
so
how
I understood. So wafer level, I basically have not shown. Wafer level is the first thing before even they
Yeah.
dissect and they dice the wafer. But let me give you a little bit of perspective why I did a divided module level and interface level. I think in module level, when you put chiplets together, it is utmost important that each chiplet is functioning after the assembly is important. So you just reuse the test pattern sets for that particular chiplets, and there may be 20 chiplets on that module. Then run them individually after the assembly and make sure that everything is passing. And interface level is what is if you are trying to check the TSVs, because TSVs are not covered in the module, chiplet level tests. So we need to get a very specific tests which are going from the bottom die. If you're talking about 3.3, 5.5D or 3D, sending all the data from the bottom axis, which is actually what 1838 proposes, which is actually mentioned in the beginning, IEEE standard.
Oh, so you mean, oh, I see. So you don't necessarily mean that die-to-die interfaces, you mean like the interface of the system to the outside world? Or do you mean
No,
die-to-die
no.
interface? Because
Die-to-die interface, I'm sending the data up the stack and getting the responses at the bottom to check all the TSVs which are connecting the stacked die. They are okay.
Yeah, that's the 1838, right,
Yeah,
Rajesh?
that is 1838. So
Yeah.
basically, if you have 3 levels of die stacked together, memory dies, and you need to make sure
Yeah.
that the TSVs are not, there's no shorts or opens or there's no problem, then you need to exercise that interface. That's why I call it interface. If you go to that picture, that will be much more clear. Go back to the picture I added.
Yeah, gotcha.
So it will be much clearer because
Oh,
module
yeah,
level,
right.
go to the picture up.
Oh, wait, here, this one, yes, yeah, okay.
Okay, so see here,
This one?
if you, yeah, correct. So now there are 3
Mhm.
dies here, and the die at the bottom, which is talking to the outside world, is talking to the balls and the package interface. But in between two, there are TSVs, right? Micro VRs and all those, and those
Mhm.
green called PTAP, the green interface, and the red interface is called S-tab. S-tab
Mhm.
means it is secondary. I don't want to go into that because I have already given the reference to the paper. But for any
Yeah.
business person or any person who is not test background, you can see that the left hand side, the data is going up to the third level of third die. What happens if those connections are not correct and some assembly issues happens? Those are through
Yeah.
silicon vias are problematic. So that is I call it interface test. So that's why
I
this.
see, okay. I think
Yeah.
then,
So that
yeah, I
what
think
it
maybe,
does is it sends the data up all the way and gets the responses down, so that because there is only access to evaluate what is happening. The response is checked at the bottom. That is a standard which 1838 has proposed. So
right.
yeah. So this is
And so how's that different from, like, say, a post-assembly test? Like to me that sounds like it's a module level type. Like all the things that you mentioned sound like module level to
Yeah,
me,
it
or
is.
do you?
It is.
I think my thinking is that, like, if you're specifically talking about interfaces, then maybe even if we did it as a sub bullet or in writing to say that part of the module level testing is to test the interfaces, and that to me makes a lot of sense. But basically, I'm thinking more of it in terms of like the actual steps, and I would consider, like, if you want to test interfaces, that you do that after assembly, so it's part of the module level test.
Yeah, okay. That I see where the confusion coming. Module level test means after the assembly, and even interface also is after the assembly. Yeah. So I just
Yeah, gotcha.
yeah. So basically, we are on the same page. The reason I broke it down because module level test, I don't expect any repair except for the memories which are inside the chiplets. What I expect at interface level, which I got the feedback from the last talk, that we can always spare and do some lane sparing if some high-speed links are broken and they are going through between bottom die to top die. Then the current CAD tools like Synopsys and all, they allow to replace those lanes by a spare lane so that can be possible. That's why I just made sure that is sort of it's an engross sort of more detailed than just testing the chiplets. That's the reason I separated interface
gotcha.
level. And because that cost, I mean, basically I'm trying to bring the financial aspect into this picture. Forget about the technology. So do we really have this budget, and does this make sense? And last year cash already sold, we do not repair. So I actually going to take that repair for chiplet level repair out of this, because normally it is not done according to current standard, but they do have interface or spare lane fixes. So these D2D interface is becoming actually more important these days. That's why I separated it.
I see. Okay, so then I guess maybe in writing that may also become more clear and say, like, one important subsection of testing the module is making sure all the interfaces work.
Correct.
And those are all the ways that you can do it. And then and I think in terms of testability or repairability, I think I would just mention what we had discussed, that people don't do a physical repair by replacing die, but rather that standards are designed, like die-to-die interfaces are designed redundant whenever they reach a certain pin count. And so it's built into the PHY that they can automatically do this repair when it's needed.
Yeah.
Gotcha. Okay. Yeah. And then I think in terms of space, I probably then at that point, when we say that, I would reference to this table, but I would probably also put that in the appendix, because I feel like to keep our 20 pages, this seems like it's a great table. But it's very specific to one topic. So I would just mention how people repair interfaces, and then we can say, see at this table, you can look
I know. I think Boone added
availability.
Boone added it is very good actually reference. So we can put all these additional, because I know we need to meet the paper length. I completely understand. And once I streamline and refine my section, we can either put this into and cost parameters into appendix. That's fine, because if people who want to take more from this paper, they can look into this. Yeah.
Sounds good. Okay.
Thank you.
I think this ones maybe have to remove the open HBI scene.
Yes, I was just thinking that as well.
Yeah.
So then, I guess, do you have any insight into XSR repairability? I mean, like, my understanding is that, like, it's not designed for repairability, because you're also just using very
serial
like, big
interface,
traces.
not directly. So it's just the way the serial interface does is that you just have extra channels if you need it, right? So it's how many channels that you need. Then sometimes if you have one channel that is down, then you just use the other one. So it's configurable to be by 1, by 2, by 4 perspectives. So I don't think they will build in the redundancies for this purpose. That's not how the serial
Gotcha.
interface will work.
Okay, okay, yeah, then I guess we can just take it out. Yeah, that's fine. I'm not sure if well, I'll do that. Let me just add a comment. Well, I guess I don't know. I'll do it here. Okay. So then coming, or like, first of all, does anyone else have feedback, thoughts on the test and probe section? All right, then let me move on to the cost structure one. I think that one generally also is in good shape. I had added here a couple of references, and I mean, this is all like Anu's work and other authors here. So I added your guys's IEEE paper. Then Mohammed, I think, or somebody gave a talk at this IEEE TV thing. So I added that link, and then the link to the actual online version. Is there any other like main item we want to point to? Oh wait, Anu already left. Never mind. Yeah, but I think so that covers it fairly well. And then here we're talking about kind of like process technology and how going to older nodes has a cost impact. And then the aspect of faster time to market we discussed last time. And then lastly, there's the open chiplet market. That one Kash had written, and I was just consolidating there and moving some of the pieces to other sections because what he was writing, as I mentioned, partially overlap with other things such as the die-to-die interfaces. But otherwise, I think I like the points that he's making, especially kind of focusing on interoperability, what is needed there. Then the question of like, or this idea of bridge chiplets, which is playing into kind of the solution that his company is working on. But generally, I think it's a fair point to say that we will eventually, like there will be a market for chiplets that go from one interface to another, or that can help translate from one protocol to another, in case that hasn't been coordinated properly beforehand. And then, yeah, and then I had like one specific comment here. He had a couple of roundabout numbers, and I wanted to talk to him about that. I think in general, the intention is good to be able to show people what may be required if you want to build a chiplet system. But I think if we do that, we need a couple more references, and B, we need to specify what exactly is meant. I think in his case, he's referring to a scenario where all the chiplets already exist, and he's trying to spec out the time and money that is required to build a chiplet system out of it. And out of the bullets here, I'm not seeing any cost item for software development or firmware, or like basically like making sure that these chiplets can actually work together. I do believe that would be like assuming that the chiplets are already built and they should be compatible. I assume that that's still a significant amount of work that is required to make that happen. But I'll send him that feedback personally. So yeah, I think those were, and then like lastly for the interface standard. Yeah, there was one, I guess this is for James. There was this one section here where you said mixing disparate interface standards with mismatched pitches adds cost. Do you mean like different pitches from the same standard, or do you mean something like a bunch of wires to UCIe?
Yeah, I think from a same standard, I think this is more point about, right? The whole session is talking about the not the standard, but more like standard format, right? So, or standard models, right? So I think here it's talking about standard model. Yeah, it's the same standard model. I think that's the point.
Oh, I see. Okay. Interface standard. Then I'll maybe just do it that
Right.
way, because I think otherwise I immediately jumped to die-to-die interfaces,
Right,
and I was
right.
like, how is that
You
going
don't
to
to
happen?
choose,
But
yeah,
okay, that makes a lot more sense.
That one is only use HPM or whatever, like POW, and then you want to actually build other, you have like
Yes.
UCIe and it, and then you come out later on, you find out,
Yes.
okay, that's not going to be good. So something you can, yeah.
Okay.
I think this kind of standard format, I think I will help identify earlier.
Yes. Yeah. And so then I have, I guess, like a suggestion. I know that it's a little bit more radical. Like I think this first subsection here is great, and it gives people at the right level of abstraction and insight into all the things that need to happen if people want to share chiplets. And I think I just added like a couple words basically saying like that's the kind of stuff we need from third-party chiplets if you want to integrate them into your own design. So I think that's good. Then I was looking here at the section about the open standard format and all the benefits it brings. And I fully agree with everything that you're saying here. My thinking was that if you just have the section alone, it makes a lot of sense. But we're also mentioning a lot of these ideas in other sections. And so in order to not be redundant, I'm proposing to possibly take some of these out. And if you don't think these ideas are covered enough, to then rather put it into these other sections. So design reusability, we're talking about that in chiplet architecture and the cost model. Interoperability, we're talking about that at, I guess, the open marketplace, for example.
Yeah, Marek, I
Yeah.
think I want to elaborate more here.
Okay.
Here is not talking about the the standard. It's more talking about the data format for the standard.
Yes,
So,
I fully, yes, I do get that from what you're writing up here. I think basically when you're saying, for example, it helps with an ecosystem, which I think fully agrees. I fully agree. There is, when I was going through this list, I was thinking about basically if you had a chiplet standard format, where does it immediately help, and where does it help as a secondary and third, kind of as a derivative benefit. So like, for example, if you have a chiplet interface standard or model, then that immediately helps with the modeling, and it helps with people describing their chiplets. And then that, of course, also helps with the ecosystem. But I wonder if, like, basically, I just want to make sure that we're not necessarily like basically adding too much, like, or when it's only like, to me, it's clear that some of these things will happen if we have that standard, but I wouldn't like spell out all, like, it looks like a list of like trying really hard about like every possible benefit of such an interface, if you know what I mean.
it's not just interface, right? I mean, like there's other things kind of like this standard existing one, I think can be used this standard as well. It's not just an interface. I mean, like it just also, I think like for other purposes, right? I think like the information, I think I kind of like the mechanical electrical information, I think like all this kind of material properties and things like that one, right? I think that will be useful in all your analysis, in all your kind of like assemblies, like processing and things like that. So I think having all this information in the standard data format will help even in the today's ecosystems. That's the immediate like benefit, right? I think even though without interfaces, I think that's new thing. But I think a lot of like, this kind of chiplet, they also reuse many of this kind of like SIP processing standard, right? So which means that a lot of this kind of like standard data format will be very helpful, like to be able to like interchange, I think, between these kind of tools, and also like I think like to help in this kind of like when you talk about like different, I think like the tester and designers, like assembler, like manufacturer, they can share the data very easily using this data format instead of like trying to kind of like read through a data sheet and try to convert themselves, or do a script to convert different format passing to in different kind of data structure, like into the format that they understand, things like that. If everyone going to be using that one standard schema format, and that data just going to flow too smoothly, everyone going to look in the same cohesive kind of data. Does that make sense to you? It's very important actually. I think we have done through the design process from end to end. When we do a lot like the simulation, the modeling, like we often get a lot of this kind of standard in different format, right? Some in XML, some in like CSV, some even like in the PDF, right? And data structure, you have to convert that. And everyone kind of every stage, they because they're different team, different people, they kind of convert themselves and not necessarily used by other teams, right? So like test made, they convert into their PDF, they convert into an Excel CSV, so they can use on the end, and then the designer convert that into their own kind of like YAML standard whatever, so they can use in the design, things like that, but they're not kind of like interchangeable in between.
Yes, no, that certainly makes sense. I think what I was trying to say is, for example, if we take test, depending on where we stand today, I would say the biggest issue to an open chiplet market system is that people even have to be willing to share test information or test programs in the very first place. And then the second step would be, ideally those should be all in the same format, so that simplifies things. But the main issue for test is, to me, like basically separating, like finding a way to share somewhat sensitive information, maybe having like basically getting people around to doing that. And so that's why I guess like so it sounds like you're advocating to have to still have all these different benefits spelled out separately, because the way what you're saying is they do make all of these different sub areas easier.
Yes,
Is that right?
Based on like in the previous session, I think that earlier meeting, I kind of expanding that.
Yes,
also.
no, exactly. No, and you did.
Yeah.
Yeah, you did make that point. Absolutely.
Yeah. The multiple interfaces, for example, now we are dealing with like almost like 10,000, 100,000 of the IOs, right? Without this kind of standard format, I mean, like, there are many redundant calls and redundant group of IOs. You possibly have to recreate them and enter them one by one. I mean, like using that strength array helps a lot. I mean, like you can have this instantiation of the the standard format. I think company are asking for that. I mean, it's not only from us. Like Intel, AHJ, one of the a company actually pushing, they want this one. So they have been creating this kind of test case themselves. I mean, like it's so tedious. They have to kind of create one by one, enter one by one. They want this kind of formula way to create that, and also like structure way, and also can reuse that, and then they can repeat that and redundant and extending on that, and even reuse a different kind of similar product that way easily without having kind of manually creating them again. So I think that's very important. And
maybe
that's
could
I
I
see this way. And that's all this
one
data.
possible other way of doing this?
I'm sorry, come again?
Yeah, I would maybe then like I would have one other proposal and see what you think. I personally like just kind of like stepping back from like the specific issue and thinking about how the paper flows. My senses would be better to mention these items with the other respective sections. So do you think it would be possible, for example, to make these points within these other areas? So when we talk about interoperability, we like say this also includes a common standard to describe all the things that you're mentioning, and basically moving this paragraph into interoperability. When we talk about design reusability, and again, we say design reusability also means we need a common standard, and then move that paragraph there. And basically, and when we talk about test, to basically mention the common format for testing in the test section. Do you think that would be acceptable?
I think that might potentially also create redundancy there, right? Because I hear interoperability is not just only for design, there's a manufacturing there also, right? Even for testing, that's applicable there also, right? I mean, it can interoperability within this kind of standard format. So if you put that way, probably you have to mention every section there. I think like this.
No. So I'm saying for some of the things that I strike through, I think these are mainly covered in other sections. The ones like like to me, when somebody says common file format, what I immediately think about is design tools, verification, analysis, testability, and simulation. All makes immediate sense. Saying that it helps with an ecosystem, I can see the connection, but again, I wouldn't say that an ecosystem, like that if somebody asked me what is the most important thing about forming an ecosystem, I wouldn't immediately go to that we also have common formats, because I think even if we didn't have them, as long as people shared all the information, that would probably be the first step, and then the second one would be to make sure they're all the same interface.
Yeah, I think
or the same formats.
Yeah, I think it's not just a format, but I think also the data format, right? I think that's probably one tiny piece,
Yeah.
probably missing the data format, right? I mean, they could be same format,
Yeah.
means the same interfaces, but we want the same interfaces also using the same data format, right? They're both using XML.
Yes, yeah, that's what I mean. That is what I mean.
Right, but I think this is what is mainly this section about, right? Because all our section, they stop there, right there, right? Using standard format. I need to be like UCIe. I don't want to using like UCIe mixed with POW, but it doesn't talk about like details about like how like when using these two different chip, right, that integrate them together. I mean like the data between them. I mean like from one chip, right, from different vendor and chip vendor, what data format, right, when they talk to each other, right? When you read into both, they both could be coming in data sheet, right? In the PDF one, that one could be have some sort of different format, right? When be in some CSV format, right, in certain IO data. So, but you want all both of them using this XML standard format schema, so that when you put all this thing together, you will get two XML schema data that you can directly like plug into your software or plug into your like analysis that you can do the comparison and run your program directly, and then without having do any extra work on it. Maybe
Okay.
let me look. I think I will over time. Maybe let me look and then refresh some of this thing, because I think that is main point of this kind of data standard format.
Okay,
It's covered everything.
Okay.
I think that's why I think you might think repeatedly, but it's more focused on data format. It's not focusing about the standard format itself, but more focusing about the data format standard that used within that.
yes, right. No, I think that comes across like maybe it could be made stronger in certain areas. As I said, but what I was trying to do is not like just to keep basically topics together and not basically if we talk about that and so that was my whole proposition, to say like for some areas where we have a specific subsection that just talks about interoperability, to move the data like a common data standard into that discussion and say, when we're talking about interoperability, there are a whole lot of things to consider. Data formats are one of them. Rather than at the end just having a section for data, like and when we talk for data formats directly, I would then go to any of the tools that directly interface with data. But if you think this is the better way to do it, then we leave it like that. I'm fine with that too.
Okay, yeah, let me think a bit. I think also I didn't think it's easier that way, because there is one standard we're trying to highlight here and then trying to get people, I think, use this standard. I think it's good to focus in one place. I think and talk about it together.
I see. Okay. So you're saying like basically this is like this CDXML work can be leveraged in all these ways. Let there be a list so that people can basically see where that applies.
Yes, and the one they look into this single place, I think using this CDXML and the JDEX Chapter-D, they can get all this benefit, I think, in one place, and then they can kind of connect the dot there.
Gotcha. Okay. Then that's fine. Those were just suggestions, but if you have like a good reason for keeping it this way, then that's good too.
Okay, yeah, appreciate that.
Malik, so just now you mentioned the firmware developments for the interchiplet operating as a cost, right?
Yeah.
I think in most cases, it may not be covered as the project cost per se, because the project cost will be more towards the hardware developments directly. Those software which is applications level is going to support across a project. So in the actual project calculations, I don't think that would be counted directly, because their intent is likely to be reduced quite in general, and then the investment from the software side directly just to overall project developments may not be a full-time there. It's just incrementals to it. So that is how it works. The data that I've seen in the past, but I'm not so sure it's true for chiplet or not.
Okay, I mean, I guess that if that's your like, I take that as feedback.
Yeah, it's just a feedback. It's not a statement. I mean, it's just a past experience feedback only. It's not,
I guess the way like specifically like applying cautious thinking and him being at your chip and their goal being to assemble like basically different chiplets into custom products for people. My assumption is that the end customer would just not want them electrically connected, but also that they can turn it on and like program it with like some higher level tool rather than like going in and setting registers on their own. But maybe that is what the customer does. And anyway, but I think I'll send it to Kash as a thought, and then you can comment on whether he thinks that's appropriate or not.
Yep. Yep. Okay.
Rajesh, did you have any other comment? I know we're already a bit over time.
Yeah. I just wanted to let you know that I'll be traveling out of country for next 2 weeks.
Okay.
So I will try to call in from wherever I am, and if otherwise, I'll just miss next meetings or 2 meetings.
Yeah, no, I mean that's totally okay. So I mean, I want to make sure that this is not like that we're not like unduly burden you with
Absolutely,
so,
yeah,
so
no worries.
so even if you have let's say if you had time to work offline on your section, you can just
Okay.
send me an email
Yeah,
and say
sounds
I've
good.
updated this and I'm happy to review it with the team, but without you being there. That's totally fine as well.
No worries. Thanks.
Rajesh, you are not joining
Okay,
you are
awesome.
not going to be there at the global summit.
Yeah, James. Actually, I also wanted to let David. I had to go, and I did not check that global summit times are right exactly the days I'm out of the country.
Okay, all right.
So anyway, I'll miss you guys. But anyway, once I come back, I'll connect with you and James.
Sounds good.
James.
All right.
Let's see what. And it is in person, right? It's not online, right?
Yeah, I think so.
Okay. Global summit. Okay, thanks.
Yeah.
See
All
you.
right. Thank you all for sticking around even a little bit longer and a good discussion. And I'll send out a email to everyone, and I think I'll ask especially to have contributed for basically going also through the entire document and helping comment on sections that they haven't written, so that we can basically get to a point where everyone can go along with all the things that are being said in the paper, and that we can get much closer to having a final version.
Sounds good.
All right.
Hey,
Thank you so much, guys.
James. Yeah, thanks.
Thank you.
James,
Thank
I'll miss the next CDX meeting. Sorry,
Oh, okay. No worries. Yeah.
because I'll be in the plane.
Yeah,
Okay,
I know.
thanks.
Understandable.
Bye.
All right.
Bye.
Okay. Yeah. Bye.
Okay.